Hello, small update to my previous OpenGL ES 1.1 texture projection demo. You can see that shadows are active for all the objects in the scene. They are active for the spheres, they are active for the foreground geometry, these three textured objects, and they will be active for the shadow receiving planes, but it doesn't make sense as they are only used to receive shadow, not to cast it on top of other planes. It's not something difficult to do, it's just something that is not done at the moment. Planar shadows usually work best when they're confined, so we need some limits to the scene, and I'm using these three planes to do so, to show you that the shadows are being properly projected onto the scene, or on this 3D scene. There is still a problem with the texture projection code as far as the back projection fix is concerned. Basically, I'm seeing a false positive in an area of the scene, which is right over here, which basically is seen as behind the projector, even though it's in front of it. The back projection fix works by using a texture, which is a black and white texture with a black pixel on the bottom left. This texture is also known as a clipper texture, which is also used by some graphic card companies to implement user clipping planes in software. And this texture use a spatial texture matrix so that all the vertices behind the plane or on top of the plane are mapped to s equals 0. I'm talking about the s coordinate. A normal texture map, you can think about it in terms of UVST coordinates, which are basically the local space of the texture, where the texture lives on. The origin of the ST coordinate system is on the bottom left of the image itself, and so basically that's where we are going to place our black pixel art. The texture matrix is going to have the first row set to the plane equation for the projector, so it's going to be taking the plane normal and the distance from the origin. We're going to have the second and third row empty, and the fourth row is just going to have a 1 in the fourth column. So basically the C and R coordinates of the texture are going to be set to 0, and the S coordinate is going to be calculated according to the plane equation. Basically, it's a way to run the plane equation for every pixel, at every pixel for the vertices we have in the scene. We are gonna do this multiplication by sending the vertex coordinate as a texture coordinate. It's gonna be multiplied by the plane equation. We're gonna have the dot product of the vertex and the plane normal, and added to the distance from between the plane and the origin, which is something that you could do in paper. You can see it works. You can see it tells you if the object is behind or on top of the plane, or if it's laying in front of the plane. If a point is on top of a plane, the equation is going to yield 0. If the point is behind the plane, the result is going to be negative, and if a point is in front of the plane, the result is going to be 1. This is enough to let us use the texture wrapping mode known as clamp to edge to make sure that for all the values, for all negative values, and for actually s equals 0, the dark texture is going to be selected, and in all other cases, so basically in the cases in which the geometry is in front of the projector's plane, the white texture of the clipper texture is going to be selected. If we multiply the texture pass by the texture we use for the regular projector, for the spotted projector, we were going to basically change only the areas of the screen that are behind the projector. For example, for this area over here, we will have the projector shining on top of it, thanks to the negative projection, but multiplying it by the result of the second texture pass, it's going to be erased, because we're going to multiply that black texel by anything. It's going to yield 0. 0 by multiplied by another color and still yield 0. It's not something difficult, except in the case in which it doesn't work, like in this area, which somehow is misinterpreted by my code. Thank you for watching. I'm still working on this code, obviously, and the two issues that I'm trying to fix are the back projection problem here, the false positive, and the wrong blending that you see in these three areas, basically where the texture projection meets the projected shadow. You can see that the projected shadows are blended with the spotlight texture. They are a little bit brighter. You can see they get brighter when the spotlight is shining on them, but not enough, not nearly enough. And the way everything is implemented right now with the multiple rendering passes, achieving a properly blended shadows that is also lit by the spotlight texture is not something trivial. Ideally, these shadows are not even meant to be blended on the scene. We are just rendering these floors again with the shadow casting light turned off in the areas that are in shadow. They cannot see the light, because this is the way that usually preferred when you think about shadowing a scene. You don't want to darken the scene, you want to stop light. You want to render the point as if it couldn't see the light source. Okay, till the next time, thank you for your patience and goodbye. Just one more thing. Here you can see the problem with the texture projection code. In just a moment you're going to see the texture disappear. It's on again because I've disabled the back projection fix. You can see that the back projection texture, the back projection still happens. Now I'm going to be disabling the code, enabling the back projection fix. You can see it disappears. But if I leave the back projection fix enabled, you see the texture disappearing here. See? The back projection fix does not affect the place in which the texture should be, mostly. These areas are lit, you can say incorrectly, not because of the texture projection method, but because of the projection itself works. If you have a projector standing between an object and yourself, and you're sitting behind the object, the way the projector is going to work is going to be lighting the front face it sees and also the back face of the object. It's easier to do it using shaders, because you could run an equation at each pixel, checking if the pixel is looking, if the pixel in that point is looking towards the projector or is looking on the opposite direction, and you could just discard it. But in OpenGL ES 1.1 it's probably a little bit more difficult, and I'm gonna have to see if I can solve it, or if I can just accept it, and as one of the many visual artifacts that sometimes still plague a rendering engine, even in a shipped title. I hope not to do that, obviously. But I mostly care about not having back projection, and that's the thing that I focus on the most at the first. Okay, thank you again and goodbye.